This video deals with the representation of single variable linear inequality using number lines. Single variable linear inequalities are inequalities with just one variable. For example, the inequality x plus 1 is greater than or equal to 7. This is an inequality. You can see the inequality symbol here, greater than or equals to. There's just one variable, the variable x. So we're going to take a look at different forms of inequalities and the manner in which they're represented on number lines. So for inequalities of the form x greater than a, where a is a constant, a number, like 1, 2, 3, 4, minus 1, minus 2, and x is a variable. For inequalities of this form, the way to represent valid values of the variable x is to take a number line, locate the number, in this case a, draw a vertical line with an unshaded circle and an arrow pointing towards the right. The arrow pointing towards the right tells us that values of x, so this number line represents values of x greater than a. In this region to the right of this a, values of x greater than a are valid values. The unshaded circle tells us that x is not equal to a. So the whole combination of this unshaded circle and the arrow pointing towards the right tells us that only values of x greater than a are allowed. So let's take an example. For the inequality x is greater than 2. You draw a number line which will contain 2. So let's start with minus 1, move to 0. So using an interval of 1 to 1 to 2, 3 to 4 to 5, and I can continue, but I'm going to stop here. And I'm going to show that, so this number line represents possible values of x, because x is a variable and can take several values. Now, we want to highlight the valid values of x that satisfy this inequality using this number line. X has to be greater than 2. So let's locate 2. You draw a vertical line and an unshaded circle because x cannot actually equal 2. And an arrow pointing towards the right to show that x takes values that are greater than 2. So any number to the right of 2 is a valid value of x. X can be 3, x can be 4, x can be 5, can be 6, can be 6.5, and so on. This is the representation of this inequality. And I'll do another example. For the inequality x is greater than minus 1, just draw another number line that contains minus 1. So start with minus 3, minus 2, minus 1, 0, 1, 2, 3. This number line contains values of x, possible values of x. I want to show the values of x that satisfy this inequality. X has to be greater than minus 1. So I locate minus 1, draw this vertical line with an unshaded circle at the top because x cannot be minus 1, and an arrow pointing towards the right because x can take values greater than minus 1. So any value of x in this region, any numerical value here, is a valid value of x. X can be 0, can be 0.5, can be 1, can be 2, can be 3, and so on. Just really simple stuff. So let's consider case 2. Inequalities of the form x is greater than or equal to a. For example, x is greater than or equal to 2, x is greater than or equal to any number really, 9. What you do is a similar procedure. You take a number line, so which will have been fully marked. You locate the number a, and you draw a vertical line with a shaded circle and an arrow pointing towards the right. You know that the arrow pointing towards the right tells us that x can take values that are greater than a. The shaded circle tells us that x can take a. So a itself is a valid value of x, unlike before where the circle was unshaded, which tells you that the variable cannot take the value of a. So I'll just do an example to demonstrate this. Let's take x is greater than or equal to 2. To represent this, I'll draw a number line that contains 2 somewhere in the middle. So I'm going to start with 0, 1, 2, 3, 4, 5, 6. So this should be a vertical line. I'll just make it thick. In order to represent this inequality, I locate 2, draw a vertical line with a shaded circle because that tells us, or tells me, that x, the variable we're trying to represent, can take a value of 2. The arrow pointing towards the right tells me or you or anyone that x can take values greater than 2. So the arrow pointing towards the right, emanating from this shaded circle, says x can take values greater than 2. So x is basically any number in this region, including 2. So x can be 2, 3, 4, 5, 6. So please note the distinction here. We have a shaded circle. For the inequality, x is greater than or equal to 9. I'll draw another number line that contains 9. So I'll start with 7, 8, 9, 10, 11, 12. I locate constant 9 here, draw a vertical line with a shaded circle. Why? Because this inequality says x is greater than or equal to 9. So the shaded circle represents this equals to component. And to represent the greater than component, I draw an arrow pointing towards the right. And this number line for the variable x shows that x is greater than or equal to 9. By now, you must be getting the hang of representing single variable linear inequalities on number lines. So we'll go to case 3, which revolves around inequalities of the form x less than a. So for example, x is less than 2. Similarly to the other cases, you have a number line. You locate the constant a. You draw a vertical line with an unshaded circle at its top. Why? Because we're trying to say that x is not equal to a, and an arrow pointing towards the left, towards the direction where you have values less than a, to show that x can take values that are less than a. And the best way to understand this is via demonstration using a concrete example. So for that inequality, draw a number line with 2. So let's start with -1, 0, 1, 2, 3, 4, 5. To represent this inequality, I locate the constant 2. Draw a vertical line with an unshaded circle because that shows that x cannot take a value of 2. And an arrow pointing towards the left to show that x takes values that are less than 2, in line with the inequality. Now I'm going to consider case 4, which deals with the representation of inequalities of the form x is less than or equal to a, where a is a constant, x is a variable. For example, x is less than or equal to 4. Similar procedure, you locate a constant on the number line. So here's the number line. Locate a constant on the number line, draw a vertical line with a shaded circle because it's less than or equals to. So the shaded circle represents that x can take a value of a, and an arrow pointing towards the left emanating from the shaded circle to show that x can take values that are less than a. So for this inequality, x is less than or equal to 4. We take a number line. So I'll just draw a number line that contained 4 somewhere in the middle. So start with 1, 2, 3, 4, 5, 6, 7, 8. To represent this inequality, we want to represent the fact that x can be less than 4 and that x is equal to 4. So for the part where x is equals to 4, I am going to locate 4, draw this vertical line, and shade the circle. Shading the circle shows this component of the inequality here, that x can equal 4. For the part where x is less than 4, I represent that with an arrow emanating from this circle, which is just above 4, pointing towards the left. As you can see, numerical values to the left are less than 4. 3 is less than 4, 2 is less than 4, and that is all. So this number line represents values of x where x is less than or equal to 4. Simple. Now to case 5, inequalities of the form a is less than x and x is less than b, where a is a constant and b is a constant. I'm going to break down this inequality into 2 inequalities. X is less than b and a is less than x. So this is 1. The other one is going to be 2. And it's a is less than x. A is less than x is the same thing as x is greater than a. If I swap position of x and a and I reverse the inequality symbol, I get x is greater than a. So in fact, this is actually 2. So let's even ignore this. So the first inequality is x is less than b. The second inequality, which is a is less than x, which I've converted to x is greater than a, is the other inequality. So we need to show two things. We need to show that x is greater than a and that x is less than b. So how do you do that? Well, to show that x is greater than a, you locate a on the number line, draw a vertical line with an unshaded circle, which means that x is not equal to a, and you draw a line pointing towards the right to show that x is greater, takes values that are greater than a. For the other inequality, x is less than b, you locate b on the number line, draw a vertical line with an unshaded circle on the top, the unshaded circle telling you that, or telling anyone that looks at the number line that x doesn't take a value of b, and an arrow or line, pointing towards the left that means that x takes values that are less than b. Now these two lines join up to give this single line, and we have this shape here. So this is what we have. And as you can see, this line in the middle covers the region between a and b, and this means that x takes values between a and b, but doesn't take the unshaded circle above a says x is not a. The unshaded circle above b tells you x is not b, and this line covering the region between a and b tells you x takes values between a and b. So this inequality here, a less than x less than b, means x takes values between a and b, but x is never a and x is never b. And we'll go through an example to demonstrate this. So here's an inequality. 1 is less than the variable x, which is less than 4. And here's a number line that we're going to use. This number line must contain 1 and also 4. So I'm going to draw a number line starting from -1. Let's go to 0, 1, 2, 3, 4, 5, 6, 7. Now this inequality can be broken down into two. X is less than 4. X is less than 4. And the other inequality, 1 is less than x. 1 is less than x, which can be converted to x is greater than 1. You just swap the position of the left hand side and right hand side of the inequality. And remember from a previous video, when you do this kind of swap, when you interchange the left hand side and right hand side, you have to reverse the inequality symbol. So our second inequality is x is greater than 1. So let's show these two inequalities. The first one, x is less than 4. So we go to 4 on the number line. Because x is less than 4, we use an unshaded circle to show that x cannot be equal to 4. And a line, in this case, pointing towards the left to show that x can take values less than 4. For the inequality x is greater than 1, we locate 1 on the number line, draw a vertical line with an unshaded circle showing that x is not equal to 1. And to show that x can be greater than 1, a line pointing towards the right. Now, this whole setup represents these two inequalities. It shows us that x is greater than 1 and x is less than 4. So values of x are confined in this region, and x cannot be 4 and x cannot be 1. It's as simple as this. So in reality, you'll draw everything in the same color. These lines will be joined up. You have something like this. Now let's move on to the next case. Inequalities of the form a is less than x, which is also less than or equal to b, where a and b are constants, just numbers. For example, 1 is less than x, which is less than or equal to 4. Now this inequality can be broken down into two inequalities. X is less than or equal to b, call this inequality 1, and a is less than x. Whoa, that's white. That works anyway. A is less than x. So I'm just going to stick with white. A is less than x. Now, a is less than x is the same thing as x is greater than a. Call this 2. I'm going to change to black. So we need to represent, this inequality is essentially made up of inequality 1 and inequality 2. So this is x is greater than a. Just changing it to black in case your screen doesn't have the right contrast to make this visible. So let's start with x is greater than a. You locate a on the number line, draw a vertical line with an unshaded circle because x is not equal to a. That's what this means. The unshaded circle tells you x is not equal to a. And a line pointing towards the right emanating from the circle telling you that x takes values greater than a, because values to the right of a are greater than a. For x is less than or equal to b, you locate b, draw a vertical line with that shaded circle at the top. The shaded circle says that x can equal b, and the line pointing towards the left tells you x takes values that are less than b. Combining these two gives x less than or equal to b. So this inequality, this setup, this diagram here, this is a number line, by the way, tells us a is less than x, which is less than or equal to b, because that's the same thing as x is less than or equal to b and x is greater than a. So let's take an example. So here's an example. Inequality 1 is less than x, is less than or equal to b. So here's our number line. Let's not use b, sorry, let's use 4, a real number. Number line, okay, start from 0, 1, 2, 3, 4, 5, 6. So this is just a number line containing possible values for x, but we want to show the valid values, the values that satisfy this inequality. This inequality can be broken out into two. X is less than or equal to 4, and 1 is less than x. So x is less than or equal to 4, first inequality. Second one, 1 is less than x, which is the same thing as x is greater than 1. Interchange the sides of an inequality, you reverse the symbol. So this is our second inequality. So let's show x is greater than 1. Vertical line on shaded circle, x is greater than 1. As you can see, values to the right of 1 are greater, hence why this line points towards the right. For the first inequality, x is less than or equal to 4, which is the same thing as x is equal to 4 and x is less than 4. So these are valid values of x. We go to 4 on the number line, vertical circle, shaded circle. So vertical line, sorry, with the shaded circle, showing that x can be 4, and then a line emanating from the circle pointing towards the left to show that x can be less than 4. This representation shows that x takes values between 1 and 4 and can take values of 4, which is this inequality 1 less than x less than or equal to 4. X can be less than or equal to 4, x can be 4 or less than 4, and 1 is less than x, or x is greater than 1. X is greater than 1. So values in this region are valid. So x can take values like 2, 3, 4. X can't be 1, x can be 1.5, and so on. Now to case 7. Inequalities of the form a is less than or equal to x, which is less than b, where b is a constant and a is a constant too, and x is a variable. Such an inequality can be broken down into two inequalities. X is less than b, and a is less than or equal to b, which is the same thing as x is greater than or equal to a. Inequality 1, inequality 2. X is greater than or equal to a is given by this vertical line with a shaded circle showing that x can be equal to a line pointing towards the right showing that x can take values greater than a. And for the first inequality, x is less than b, vertical line with an unshaded circle telling you that x can't be b, but a line towards the left saying x can be less than b. So here's a representation, and the best way to demonstrate this is with an example. So consider inequality 1 is less than or equal to x, which is less than or equal to 4. So take my number line. This will be quick here. 0, 1, 2, 3, 4, 5. This shows valid values of x, possible values of x. Now we want to show the valid ones, the ones which satisfy this inequality. So x is less than 4, sorry. So the first one is that x is less than 4. The second one, second inequality, is 1 is less than or equal to x, which is the same thing as x is greater than or equal to 1. Just interchange the sides of the inequality and reverse the inequality symbol. X is less than 4, locate 4, vertical line, on shaded circle because x can't be 4, and a line pointing towards the left emanating from the circle because x takes values less than 4. For x is greater than or equal to a, we have to show that x can equal 1, and x can equal 1 and x can be greater than 1. So for the inequality x is greater than or equal to 1, it can be broken down further into this and this. X equals to 1, show this with a vertical line with a shaded circle. For x is greater than 1, a line pointing towards the right of 1. And thus this inequality represents 1 less than x, which is less than 4. That's it. If you've been able to get to this point of the video, without any problems, then this case 8 is going to be easy. We have an inequality to form a is less than or equal to x, which is less than or equal to b, where x is a variable, the variable whose values we want to show on the number line, and where a and b are constant. Such an inequality can be broken down into two inequalities. X is less than or equal to b, a is less than or equal to x, which is the same thing as x is greater than or equal to a. So this is one of the inequalities, and that's the less than, and this is the second one. For x is less than or equal to b, we have to show that x is equal to b with the shaded circle, and that x can be less than b with this line. For x is greater than or equal to a, we have to show that x can equal a with this shaded circle, and that x can take values that are greater than a with the line pointing towards the right of a. And that's all. So a quick example: 1 is less than or equal to x, which is less than or equal to 4. We calibrate the number line, so we'll start from -1. For instance, 0, 1, 2, 3, 4, 5. Break down this inequality into two inequalities: x less than 4, less than or equal to 4, and 1 is less than or equal to x. Which same thing, x is greater than or equal to 1. To show x is less than or equal to 4, we need to show that x can equal 4. Shaded circle above 4 says x can equal 4. Line emanating from the circle towards the left shows that x can take values less than 4. Similarly, for x is greater than 1, we locate 1 on the number line. Because x can equal 1, use a shaded circle above 1. And because x can take values that are greater than 1, a line emanating from the circle pointing towards the right. So you have something like this. And this inequality shows that x can take values between 1 and 4, inclusive of 4. So this shaded circle says x can be 1. This shaded circle above 4 says that x can be 4. And this line in between these values says x can take any value between 1 and 4. So x can be 2, can be 3, can be 2.5. Any value in this region on the number line. Any of these values, 2, any of these values, 3, any of these values. So that's the solution. So here's an example question. So far we've just been drawing number lines of given inequalities. This time we need to identify the number line that represents a given inequality. Question says, which of the following number lines represents the inequality x is less than or equal to 5? So all these number lines represent values of 5, and we need to show the values of x, and we need to show the valid values of x, i.e. the ones that are less than or equal to 5. So this number line means what? It means x is not equal to 5, but x can be less than 5. Unshaded circle shows that x is not equal to 5. Here the unshaded circle shows that x is not equal to 5, but the arrow pointing towards the right shows that x can be greater than 5. The number line here has a shaded circle above 5, which means x can equal 5, and the arrow pointing to the right tells us that x can take values greater than 5. Combining these two gives x is greater than or equal to 5. This number line similarly tells us that x is less than or equal to 5. The shaded circle tells us that x can be equal to 5. The arrow pointing towards the left tells us that x can be less than 5. We are required to identify the number line telling us x is less than or equal to 5. And that's this last number line, this one here. This is the correct option. Here's another example question. This says, asks which of the following number lines, so there are 4 number lines here, here's one, here's another, and here's the last one. Which of the following number lines represent the inequality 0 is less than x less than, and x less than or equal to 5? An easy way to solve this is to just write down the inequalities represented by each of the number lines. Here we have 0 is less than x less than 5, because the circles are unshaded, so we know that x can't be 0. Because the circle is unshaded above 5, we know x can't be 5, but because we have this region, we know x is less than 5, and because the line connecting the two circles passes through this region, we know that x is greater than 0. So we can literally draw this and draw this to meet, and the region here is between 0 and 5. Here we know that the region is basically between 0 and 5, But we know because of this shaded circle, we know that x is less than or equal to 5. Here we know that this region spans 0 and 5. Because of the shaded circle, we know that x is also equal to 0. Here we know that this region, we can see that the region spans 0 and 5. So 0 here and 5 here. And because both circles are shaded, because this circle is shaded, we know that x can be 0. Because the circle is shaded, we know that x can be 5. So we want 0 is less than x, less than or equal to 5. And that's this number line here. So another way to solve this problem is to take the inequality and represent it on a number line. So we can use the technique we've been using in the previous videos. So we have x is less than 5 as one of the inequalities. And 0 is less than x, which is the same thing as x is greater than 0. So it's one inequality we need to show, and another. So x is less than 5. Well, we'll have 5 somewhere on the number line. Because x is less than or equal to 5, sorry. Because x can be equal to 5, we shade the circle above 5. And we know that to show that x can take values less than 5, we draw a line pointing towards the left. For x is greater than 0, take 0 on the number line. A line above 0 with an unshaded circle because x can't be 0. And a line towards the right because x can take values greater than 0. So which inequality looks like this one? This one. So you know that this is the number line representing the inequality 0, less than x, less than or equal to 5. So the two ways to solve this problem are to take the inequality and actually draw the inequality using the approach that has been discussed in previous videos, or to just inspect the number lines and deduce which inequalities they represent. It's using the fact that the circle is shaded or the circle isn't shaded, and also looking at the region that the line connecting the two circles spans.